In this video, I'm going to show you how to use the program for calculating quantile treatment effects. Begin by going down to the button where the program is located. It's right here, quantile treatment effect. When I click on the button, a set of instructions for how to use the program appears in the description box. I'm not going to go through these with you because I'm going to be showing you how to use the program here. And then down here is the input values box, and this is where we input information to do the analysis. And this example uses raw data from my computer, so I'm going to go get the data file. I'm going to click on Choose File. It's in the folder CRET2, and the name of the file is quantunion2r.txt. When I get the file, a list of variables in the data file show up here in this box. This is very important because R is case sensitive, and when we specify variables in the input values box, we have to respect the capitalization that's in the variables. Okay, up here I'm going to put the folder where the file's located, and I'll repeat the file name. This is so the program will know where on your computer the data are located and be able to get it there. Okay, before we input information into the program, let me make some comments about quantile treatment effects. I assume you've read the material in chapters 6 and 8 on quantile regression, as well as, and this is important, the document for chapter 8 on my webpage titled Quantile Regression Applied to RETs. If you've read this material, this means that you're already familiar with quantile treatment effects in conditional and unconditional quantile regression. You can review quantile treatment effects by watching the video associated with the program Quantile Plots on this webpage. As discussed in my book, there are two types of quantile regression: conditional quantile regression and unconditional quantile regression. You can calculate conditional quantile treatment effects using the quantile regression program on this webpage. To calculate unconditional quantile treatment effects, you have to use the current program. The differences between conditional and unconditional quantile regression are complex, and I discuss them in Chapter 6 and in the document on my webpage for Chapter 8, Quantile Regression Applied to RETs. I do not repeat this material here because doing so will result in a very lengthy video. The current program offers two methods for determining unconditional quantile treatment effects in the presence of covariates that you want to control. One method has been developed by FERPO in 2007, and this approach can only be used with a binary treatment variable, such as a dummy-coded intervention versus control variable. Covariates you seek to control, however, can be binary, nominal, or continuous. The second approach is known as the residualized quantile regression approach, or RQR, and was developed by Borgen and others in 2022. It can handle the estimation of unconditional quantile treatment effects, but for cases where the treatment or target variable has two or more values. This makes it more flexible than the VERPO method. The data I'll analyze to show you the approaches is from a study that examines the effects of being a member of a union on wages. Wages are measured as annual income in units of thousands of dollars. So a score of 1 represents $1,000, a score of 2 represents $2,000, and so on. Now suppose one of my goals is to examine the effect of being in a union on wages for low wage earners who are in the 20th quantile, for middle wage earners who are in the 50th quantile, and high wage earners who are in the 80th quantile, while controlling for age, education, and ethnicity. A second goal might be to estimate the effect of educational background, measured as the highest grade completed in school, on wages at different points in the unconditional wage distribution, while controlling for age, union status, and ethnicity. Let's go through the program and look at the effect of union status on wage first. The outcome variable is wage. The treatment variable in this case is union status, if they're in a union or not. This is the percent of the confidence interval I want to focus on. And this program uses bootstrapping, so this sets the number of bootstraps that I want to use. And this is to indicate if the treatment variable is binary or if it has more than two values. And in this case, union status has two values, either in a union or not, so it's a binary treatment. Down here, we list the covariates that we want to control for, and that will be age, grade, and ethnicity, which is dummy coded as D white. It's scored white or non-white. And I list the covariates exactly as they appear in the file, and they're comma delimited with no comma at the very end. I click on register input to have my website generate the R syntax for you. That's here in the R syntax box. Then I hit copy to clipboard. I start R. Here in the upper left, I hit Control V to paste the syntax, and as it pastes, it will execute. Here it's going through the bootstrapping, so we have to be a little patient. The bootstraps take a while. This has like a progress bar for us. And in this case, union status is dummy coded 1, 0. And a 1 is you're in a union, and a 0 is you're not in the union. And so this will be looking at the wages of people in a union minus wages of people not in a union. And that'll be the treatment effect. And we'll be looking at that at different quantiles. Again, I'm bootstrapping the RQR method here, so we have to be patient on that too. It's a little slow. Okay, the output is in blue and the syntax is in red. And so we'll go to the beginning of the blue. And the program gives you both methods for estimating the quantile treatment effects when you only have a binary treatment, both the FERPO method, and then down below it is the RQR method. So we'll take a look at the FERPO method first. In this column are the different quantiles, and they range from 0.05 to 0.95 in increments of 0.05. This is the quantile treatment effect that was observed at the 5th quantile. This is the one that was observed at the 10th quantile, the 15th quantile, and so on up through the 95th quantile. This is the standard error of the quantile treatment effect, and this is the confidence intervals, 95% confidence interval for that. If the confidence interval has the value of 0 within it, then this quantile treatment effect is statistically non-significant. In this case, none of the confidence intervals have 0 within them, so all of these quantile treatment effects are statistically significant. Because they're all positive, it implies that people who are in unions earn more dollars than people who are not in unions. If I look at the 20th quantile to see what's the effect of being in a union, you can see that the 20th quantile is $1,605. So that people in unions, as indicated at the lower end of the distribution by the 20th quantile, earn about $1,605 more than people not in unions. If I look at the median quantile of 0.5, the union versus non-union difference is $2,348, which is statistically significant. And then if I look at the 80th quantile, the difference between union and non-union workers is about $3,000. So what we can see is there's a wage differential between people who are in unions versus people who are not. And that wage differential tends to get larger as income goes up. At the 20th quantile, the quantile treatment effect is 1.605. At the 50th quantile, it's 2.348. And at the 80th quantile, it's 3.009. This particular package also reports the average treatment effect, which is just the mean difference between unions and non-union members. So this is a more traditional analysis. And notice that the mean difference does not reflect the differential dynamics that are going on at the lower end of the distribution, in the middle of the distribution, and in the upper end of the distribution. These are the results for the RQR method, and they're very close to what we found with the FERPO method. I won't go through them, but the output is set up exactly the same, and the results are comparable. Okay, so that's the analysis of the union status. Let's take a look at education. So I'm going to come back up here, and I'm going to change union to grade. I'm going to indicate that this is not a binary variable, that it has more than two values, and I'm going to remove it from the list of covariates and add in the union status to it. Again, I'll be looking at the quantile treatment effect for grade on wages. So with grade, I'm going to be looking at the effect of 8th grade versus 7th grade, or the quantile treatment effect for 8th grade versus 7th grade, 9th grade versus 8th grade, 10th grade versus 9th grade, and so on. And just like in standard regression, I'm going to be documenting for every 1 unit that grade goes up, how much do wages change, holding constant age, union, and ethnicity, and focusing on quantile treatment effects instead of means. Again, just to reinforce from the material that I cover in my book, we are controlling for a set of covariates, but we're not controlling for them by conditionalizing on them, as is done in traditional regression. Rather, we're using a form of marginalization in order to control for them. So it's a different way of controlling for these variables that allow us to look at unconditional effects rather than conditional effects. Okay, I hit register input to generate the syntax. Here's the syntax here. I hit copy to clipboard. I open up R. I hit Control V. And in this case, the program skipped the FERPO method, and it went straight to the RQR method. And it's doing the bootstrapping for it now. Okay, here's the output for it, and you can see it's just the RQR. And again, it's set up just like before. Here's the quantile. Here's the estimated quantile treatment effect, standard error, and the confidence intervals for it. Again, we can see that none of the confidence intervals contain the value of 0, so all of these effects are statistically significant. So from this analysis, we can see that for the 20th quantile, the result is 0.5207, and that means that the 20th quantile for people in a grade higher is $521 higher than the 20th quantile for people who are in one grade lower. For the median, the quantile treatment effect is $884. So the median income for people in a given grade is $884 greater than the median income for people in one grade lower than that. And here at the 80th quantile, the value of the quantile treatment effect is 1.225, or $1,225. So for people who are in a given grade, the 80th quantile is $1,225 higher than the corresponding quantile for people in one grade below that. Okay, that's the basics of the program. And again, I give a lot more detail in my book, so take a look at that. Thanks a lot.